Hello my dear friends, I welcome you in my channel Eduscope. In this video I am going to describe the fifth step of recombinant DNA technology. In the recombinant DNA technology there are 10 steps. I described number 1, that is selection of the desired character, number 2, isolation of the DNA having the desired gene, fragmentation of DNA by restriction endonuclease, and isolation of DNA by the process of gel electrophoresis. This part described. After that, the fifth step, amplification of DNA by P.C.R, polymerase chain reaction. Today's topic is polymerase chain reaction. Polymerase chain reaction, in short, it is called P.C.R. By the process of gel electrophoresis, we have got small pieces of the desired gene. Now, these genes are to be copied in several numbers by this process P.C.R. So, the process of making many copies of gene is called amplification of gene, and that is done by a technique called P.C.R, means polymerase chain reaction. In the year 1985, Kary Mullis invented this technique P.C.R, means polymerase chain reaction, to get number of copies of the desired gene. It is nothing but a photocopy or xerox of a particular page to get number of pages. Now I am coming to tell you what is the requirement of polymerase chain reaction. That is, number 1 is gene of interest. Number 2, high temperature, that should be 94 degrees Celsius. Third is primer. Primer is a oligonucleotide which are very much essential for this process. And next is DNA polymerase enzyme. Here a particular DNA polymerase called Taq DNA polymerase, which is obtained from Thermus aquaticus. Polymerase chain reaction is having 3 steps. Number 1, denaturation. Number 2, annealing. And number 3, extension. By the process of denaturation, the double-stranded DNA breaks up. And during annealing, in the 3' end of the DNA, a primer is added. And in extension steps, that polymerisation takes place to get the copy of the DNA. During the first stage, denaturation, the DNA fragments is heated up to 94 degrees Celsius, and this DNA breaks up to make 2 separate strands. This process is called denaturation. During the second phase, annealing, in the 3rd prime of the DNA fragments, which acts as template, here a primer is added. Primer is added. This primer is nothing but a oligonucleotide, and here also a primer is added. During extension or polymerization, that is the 3rd stage of this process, polymerase chain reaction. In the process of extension, from here polymerization takes place. That means deoxyribonucleotide is being added with it with the help of one enzyme, that is Taq polymerase. Why Taq polymerase is used here? Because it is thermostable, because it can bear higher temperature. This process takes place in high temperature, that is 72 degrees Celsius. So polymerization takes place from this side, and from this chain it will go this side. If it continues, we are getting 2 separate DNA fragments. But we have to remember, here Taq polymerase plays an important role, and deoxyribonucleotide is being added in presence of one magnesium, in presence of magnesium ions. This magnesium ion also plays a very important role in the process of extension. And in this way, we are getting 2 separate fragments from the, in this way, we are getting 2 different DNA fragments from a single one. And as soon as one cycle completes and second cycle starts, in this way this process goes on, and we are getting billion of copies of gene. And if it continues n number of cycle, n cycle, suppose n cycle, we will get a 2 to the power n number of DNA fragments. By this process of polymerase chain reaction, scientists are getting number of copies of small DNA fragments. These small DNA fragments are incorporated into the vector. So if you like this video, please subscribe my channel Eduscope. Thank you very much for being with us for a longer time.